Hello and welcome to the AICE Chemistry lecture series. In this video, we're going to start looking at chapter 13, starting with section 1. Now, chapter 13 is fairly short, but it does connect to chapter 15 later on. So it is important to pay attention to not just the reactions here, but also the environmental impacts we're going to see about nitrogen in the environment. So let's get started. Now, this chapter has just 3 short sections. The first looks at nitrogen gas as a compound and its reactions in the atmosphere. The second one is going to look at ammonia, one of the main chemicals that are prevalent in industry that have nitrogen at its core, and the ammonium compounds that are created by ammonia. And then finally, we're going to look at nitrogen oxides in the atmosphere and the environmental impacts that nitrogen and its compounds have in both the environment and in human life. So let's start with section 1. So section 1 is just going to be about nitrogen gas. We're going to look at its structure really quickly and some of its reactions. So nitrogen gas, which is N2, is one of the most unreactive chemicals on Earth, especially naturally occurring chemicals. Nitrogen makes up approximately 78% of all the Earth's atmosphere, so all the gases that we have in the air. And it's mostly inert, it's unreactive, and that's mainly due to its structure. When nitrogen gas gets created, 2 nitrogen atoms, which each have 5 valence electrons, are going to bond with each other, creating a triple bond in the nitrogen. Now, this triple bond and the nature of the nitrogen molecule is why nitrogen is so unreactive. Nitrogen is going to exist as a diatomic molecule with a triple bond, which has 2 major properties that make it unreactive. The first is the fact that the nitrogen molecule, because it has 2 nitrogens in it, is nonpolar. As we have talked about before, polarity is kind of like the mother of reactivity in molecules. Usually when something reacts, it's because it's attracted to some magnetic attraction. Negatives attract positives, so polarity makes a compound or a molecule more reactive because it gives an attraction. It gives something to be attracted to, a positive or a negative, depending on the side of the molecule. But because nitrogen has 2 atoms of the same element, nitrogen, which are have a really high electronegativity, but at the end of the day, the same electronegativity of 3.0. The electronegativity of nitrogen is 3.0. It's going to be neutral. These 2 elements have the exact same pull on the 6 electrons in the triple bond, so there is no partial positive, partial negative side. That fact that the molecule of nitrogen is nonpolar makes it very unreactive. The other thing that makes nitrogen very unreactive is the sheer amount of energy that it takes to react nitrogen. Because of that triple bond in nitrogen being so strong, because there's 6 different electrons that are attracting the nuclei of each atom, it has a really high bond enthalpy. The bond enthalpy of nitrogen is around 944 kilojoules per mole. So it takes almost 1,000 kilojoules of energy to break up the triple bond in 1 mole of nitrogen. That's extremely high. That's among some of the highest bond enthalpies in really any molecule. And so these 2 things, the fact that nitrogen does not attract things because it's nonpolar, and that it takes so much energy to break up a nitrogen bond, it makes nitrogen extremely unreactive. It requires that massive amount of energy to break apart the nitrogens from each other, even if something were to be attracted to them, which it's not because it's nonpolar. So that's what leads to nitrogen being unreactive. And you have to think about this. You have to be able to explain it, because when you take the AICE exam, in paper 2 especially, you might be asked to explain why nitrogen is unreactive. And these are the 2 points that you should bring up. It's nonpolar because it's 2 of the same atom bonded together with the exact same electronegativity, and it has a very high bond enthalpy because of the triple bond holding the nitrogen molecule together. Now, that does not mean nitrogen does not react. Nitrogen is unreactive, but it does undergo some reactions. Mainly in the atmosphere, when lightning strikes, it provides enough energy to break that nitrogen-nitrogen triple bond. So the only time that nitrogen naturally reacts in the air is during lightning storms, during lightning strikes. What happens when lightning strikes in the air is that it gives enough energy to trigger the oxidation of nitrogen. And this is a very important point. Make sure that you understand that this is an oxidation reaction where nitrogen is oxidized and it turns into a few different chemicals because this creates a chain reaction. So nitrogen in the air, N2, is broken apart by lightning and it ends up reacting with oxygen. When this happens, because oxygen is in the air, it creates nitrogen monoxide, NO. And this is a reaction that is triggered by lightning. Nitrogen gas plus oxygen gas create 2 moles of nitrogen monoxide. However, nitrogen monoxide is actually very reactive. Nitrogen monoxide, unlike nitrogen, reacts fairly well. So that nitrogen monoxide in the air is also going to get oxidized. So both of these are oxidation reactions. The nitrogen monoxide that's created is going to react with more oxygen in the air, because again, the air is full of oxygen, and it's going to create nitrogen dioxide. So it's a 2-step oxidation where the nitrogen becomes nitrogen monoxide by getting oxidized by oxygen being added, and then the nitrogen monoxide gets further oxidized by oxygen, creating nitrogen dioxide. That nitrogen dioxide that's created can then react with water from rain, from condensation, and more oxygen, again in the air, to create aqueous nitric acid. Why aqueous? Because this nitric acid is created in rain. So this 3-step process, it's one of the ways in which nitrogen fixation happens. Now, nitrogen fixation, that process, I'm going to write it here, happens in 2 places. One is in bacteria on the ground, but we're not going to discuss that because that's a biology discussion. But chemically, non-biologically, it happens through this reaction, with nitrogen being oxidized when lightning strikes into nitrogen monoxide, which is then further oxidized into nitrogen dioxide, which eventually creates, after reacting with water from rain, nitric acid. So this process is actually natural. This is why rain is actually slightly acidic. This is not acid rain, and that's very important to say. This is not the reason for acid rain because this process is natural. But if this process happens too much because of extra nitrogen oxides in the air, that's what leads to acid rain. And we're going to look at that in the last section of this chapter. But for now, this is just the natural process that happens where rain is going to be slightly acidic, and it creates nitrate ions. And those nitrate ions are very important because they're ions that plants can use to make proteins and other nitrogen-containing things like DNA. So this is actually a very important natural process for nitrogen fixation, for the creation of nitrogen that's usable by plants and animals and all the such. But that's it. That's the basics of nitrogen in the air, the nitrogen structure, as well as the reactions that it undergoes. And that's it for section 1. We'll keep talking about nitrogen and its compounds in section 2 and the rest of the chapter. For now, thank you for watching, and I'll see you in the next video.